such that the bigger base come first, and then on top of it you put the box that has either the same base or smaller. So you cannot put a box with a bigger base over smaller base. So the base must be smaller than the one below that object. So we will put group of boxes on top of each other again, and the base of the first block must be the biggest, and then smaller, 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 and so on. What you can see is actually the other thing, the other constraints, or the other actually option that you have, is that you can rotate the box as you like. You can switch, so the bases might be different. So for example, in this in the input, the example given to you in the TMA, the box one has the sizes 4, 5, 2. So you can say that the base is 4 by 2 and the height is 5. Somebody might say the base is 5 by 2 and the height is 4, and so on. You can rotate the dimension as you like. So based on this, you need actually to describe how a brute force approach algorithm would solve the above problem and explain the complexity. Brute force means you need to try every single possible solution from the domain of solutions. So brute force means you need to try all options. What does this mean? Means for box 1, you need to try when it is 452, and then try when it is 524, or you try when 245, and then try with 2454. So these are the possible solutions for box 1. And then the same thing for box 2, and box 3, and box 4. And try these sets of combinations until you come up with the best solution. This is called the brute force. So you need to describe how it can solve it and what is the complexity of this solution in terms of big O notation. Till this point, do you have any questions? Yes, this is your task. We have go through many algorithms and we analyze the code to see what is the complexity. We say what every single action taken, for example, it take O of 1. If we have for loop, then it take O of n. If the for loop go through all the numbers, then yes, O of n. If you have nested loop, then it takes O of n square. If for some reasons there is only halfway, then we take log n. We already go through this analysis. Yes, so that is for the first point. Okay, now the second point is to design an algorithm to solve the above scenario, assuming that you have n boxes. Now here what we want is the solution. Your solution is not the brute force. We want from you a new algorithm to solve this problem, and you need to also analyze the complexity of your algorithm, the new one. Not trying one by one like brute force. You need to design a new one to solve this problem. Third, what will happen to the complexity? Now you are actually, when you design a solution for this problem, there is one constraint in the problem, which is the base, right? We cannot put or place on top of another box unless the area of the 2D box is smaller than or equal to the 2D base of the lower box. So here we have if condition, right? Here we need some operation, and then we have if condition. Let's say that this constraint is not existed. how this kind of constraints is affecting your code and the complexity of the code. If you take out these constraints from the code, will the complexity become better, the efficiency become better or lower? This is for number 3. Please, if you have any questions, stop me before I move to the next one. Yes, Salama. Okay. Right. Now, the fourth one is to develop Python code to implement your efficient algorithm. That's it. This is the code. The second question, I think it's very straightforward. You will be given a blank wood, a blank of wood. Okay, this plank of wood has a specific length. Now, you will be given actually different lengths. You will be requested to cut it into different lengths, and each length had different price. You need to cut this plank of wood into separate pieces to maximize your profit. For instance, let's say I give you one plank of wood which has the length, for example, 4 units. The units can be for meter, 4 centimeters, 4 millimeter, whatever. Let's consider it 4 meter. So the length is 4. Now, the inputs of the length that are available for you to cut is 1, 2, 3, 4, 5, 6, 7, 8, which means you can cut each piece into a smaller piece of 1 meter, or 2 meter, or 3 meter. But where is the problem? If you cut the piece, every single piece of 1 meter, you can get a profit of $2. Each piece of 2 meters will get a cost of $6, and so on. So the question is, if I give you a plank of wood of a length 4 meters, what is the best possible cuts for the pieces which can make my profit the maximum? There are actually so many options. You need to list the options which can lead you to number 4. So either you keep it as it is, this is one size because I have one cut which is 4, so I can leave it as it is. Then the customer will give me $10 because the piece of size 4 costs $10. So I will take $10. What are the other possible solutions? There are so many solutions. Actually, I can cut it into one piece 1 meter and one piece 3 meters. Then I can get another 10. I can cut it into 2 pieces, each one 2, 2. I can get 12 pieces. I can cut it to 3 and 1, 10. 1, 1, 2, 3 pieces into 1, 1, 2, or 1, 2, 1, or 2, 1, 1, or 1, 1, 1, 1. But if you look at the calculation, the profits, you will find that the best cut is to cut it into 2 pieces, each one of size 2. So I can get $12 instead of 10 or 8. Is the explanation clear? Okay. Now, the questions are, describe the algorithm or an algorithm that may examine all possible solutions. Have you seen the cuts? These are actually, every single cut is a solution. So you need to describe an algorithm to examine all the possible solutions. Or even use recursion to solve the above problem, whatever solution. And then after you describe the algorithm, you have to determine the complexity of this algorithm. The second is, develop a brief report to explain the drawback of using such method. The method you have described in A. What is actually the drawback of developing such a method to solve the similar problems? يعني احنا, this particular method is suitable for this particular problem. What will be the problems if I am applying this method over similar problems, not the same problem? Number C, use appropriate method to turn the algorithm in A into more efficient one with less complexity. What changes you should make? And lastly is implement the efficient algorithm using Python. Is it clear? Okay. For question number 3, I think it's very straightforward. It is just finding the complexity. You have the code and you need to find the complexity. It's better, Yalama, yes. And that's it. So we can start now with our class.